Dear students, so now we are going to discuss the first unit in the control system. So in that, see here, the first unit is modeling of linear time invariant system. So in the first topic we are going to discuss that basic elements in control system, open loop and closed loop systems with practical examples. So here we are going to discuss the four practical examples of open loop and closed loop system. So now we are going to discuss that basic elements in control system. See here, in any system, it will be having two elements. The first thing is input and output. So now see here that basic structure of system. It contains input. So in that input we have different types of inputs are available. Manipulated input, disturbance input, command input, reference input. So the next thing is error detector. The next thing is controller, control signal, error signal, final control element, and control system. So and also we have the disturbance variable and control variable. So the very important element in that control system is feedback. So it is a function of control variable. It is used to correct the nonlinear in the control system. The next thing we are going to discuss the classification of control system. So we have different types of control systems are available. The first thing is open loop and closed loop system. Second thing is linear and non-linear system. Third thing is time invariant and time variant system. And the fourth thing is continuous and discrete system. And the next thing is single input, single output system and multi-input, multi-output system. And further we are going to discuss the lump, distributed, deterministic, stochastic and static and dynamic system. So now see here, the open loop system. We are going to discuss about the open loop system. So a control system in which the control action is totally independent of the output system. That means, so any physical system that will be not automatically correct the variation in the input means that is called open loop system. And also this open loop system has no effect upon the input quantity. So and very important thing in that open loop system that output is not feedback to the input for the correction. So this is the block diagram for open loop system. We have input, for that input we have the corresponding output response. There is no feedback present in the system. So that is the open loop. So here that open loop system that output can be varied by varying the input. So due to the external disturbance, the system output may change. But when the output changes due to disturbances, it is not followed by changes in the input to correct the output. So in that open loop system, the changes in the output are corrected by changing the input manually. So the example of open loop systems are light switch. So we can the lamp glows whenever the light switch is on, irrespective of the light is required or not. Then the second thing is, so we can take the fan example. So you need to manually correct the speed of the fan. So these are the examples of open loop system. The next thing is, here we are going to discuss the merit and demerits of open loop system. So the systems are simple and construction and design and easy to maintain, economical, stable. And the demerits are systems are inaccurate and not reliable. Rehabilitation of the controller is necessary time to time. And the next thing is closed loop system. So in that closed loop system, the output has an effect upon the input quantity. In order to maintain the desired output values are called closed loop system. So the open loop system can be modified as closed loop system by providing the feedback. The provision of feedback automatically correct the changes in the output due to disturbances. The closed loop system is also called automatic control system. So the general block diagram of automatic control system is, see here, here we have reference input. After that, the input is going to controller. Next, the open loop system. So after processing the output, again the feedback signal goes to error detector. So in that error detector, it will be correct the error. So now see here, the feedback path element samples the output and convert to the signal of same type as that of reference signal. So the feedback signal is proportional to the output signal and it is fed to the error detector. So the error signal is generated by the error detector is the difference between reference signal and the feedback signal. This is very important here. The error detector part, it computes the difference between reference signal and feedback signal. And then the controller modifies and amplifies the error signal to produce the better control action. So this modified error signal is fed to the plant to correct it out. So the example is we can do any automatic system. So here the example of closed loop system is automatic electric ion, air conditioner, water level controller. So like that. So that merit and demerits of closed loop systems are accurate and reliable and reduce the effect of nonlinearity and disturbances. Operating frequency zone is high. And the demerit is that closed loop systems are complex and costly. The feedback in the closed loop system may lead to oscillatory responses and also it reduces the overall gain of the